The following program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
Hey, and welcome to Major League Soccer. Joining me to call the game today is Julie Foudy. Julie, welcome aboard.
Thanks, Greg. Glad to be here.
So, did you bring it?
I did. I sure did.
Oh, for those of you who don't know it, Julie is an Olympic gold medalist soccer player. Oh my gosh, can I hold it?
Oh, sure.
Great. Wow. Whoa, it's kind of, it's a lot heavy. Whoa! We'll be right back.
SportsFigures. Put your brain in the game.
So what subject in school do you think of when you think of soccer?
Trigonometry.
Trigonometry.
Trigonometry? Exactly what I was going to say. Trigonometry. Trig. So what is trigonometry and what could it possibly have to do with soccer? Trigonometry is the study of this, triangles. That's what the word means in Greek. Tri for triangles and gonometry for measurement, the measurement of triangles. Soccer, from the American word for socks, and kur, from the Armenian word for high socks, soccer. Let's say you're coming down the field with the ball. Now, you can either stay right in the middle or break to one of the sides to take your shot. Which place is going to give you the best chance of scoring? Now, this is where strategy comes in. Tiffany, I think your sock is down. Goal! This lady behind me here is Julie Foudy. Julie has over 100 international appearances for the USA. She was co-captain of the women's team that took the gold in Atlanta in '96, and she's currently training for the Women's World Cup. That's going to take place in the USA in 1999. Excuse me.
2, 3, 3!
Julie, where do you take your shots from?
If I had my choice every shot, if this was a perfect world, I, Greg, would take my shots right here in the middle.
Okay, why the middle? Why the center of the goal?
Because if you look, I have the whole goal to work with here, okay? You're going to have a goalkeeper, of course, in the middle of this goal, but they can only cover so much of that goal. I have the whole goal, so I have my full angle here. Okay. I can shoot it right, I can shoot it left.
Okay, no, let's say, well, why not kick over here?
See, as you move outside, your angle is cut down. The goalie can come off her line and cut it down. So now I may have just the left side of the goal, but she's probably going to cut off the right side of the goal. So the further out I move, the less goal I have to shoot on. Makes it a lot harder.
Could it be that much better? Let's say we wanted to take a shot from I don't know, right over here at the corner of the penalty box. Could it really make that big a difference?
Yeah. Oh, yeah.
Okay, you guys, how can we figure out the advantage of a center shot over a shot taken off center?
We could figure out the angles. Well, if you wanted to use trig, you'd have to have triangles.
Okay, let's try it. Let's start here, off center of the goal at the corner of the penalty box. Next, we'll draw the potential angle we have to score. The potential area we have to score is the width of the goal mouth. Okay, so what have we made?
A triangle.
Right. If we take these two sides and the goal as a side, we have a triangle that shows the area the ball could go through to score.
Wait a second. What about a goalkeeper?
Oh, right. We have to work a goalkeeper into our problem. Tiffany, why don't you go on down? Okay. Tiffany, if someone were going to take a shot on goal from over there, where do you think you'd stand?
I'd stand right about here.
Okay, so given the speed of the ball and your reaction time, let's say that you can cover 6 feet in either direction. We'll call this our line of defense. Now, this shows the effective area of goal that Tiffany here can cover. We'll draw a new line from our kicker to the end of the goaltender's line of defense. That gives us a new triangle. Okay, so there's our problem. This triangle shows the total angle to hit the goal, but this smaller triangle shows the angle that we could actually score. If we could figure out these angles, we would have an exact number for our effective scoring angle from this side. So, Jennifer, how do we figure out the angles?
Well, we could use trigonometry, but we don't have a right triangle.
Right. The key to working with plane trigonometry is having a right triangle. What that means is that one of the triangle's angles is 90 degrees. The great thing about trig is that if you have a right triangle, you can figure out a lot of stuff really easy. But you need a right triangle. But Heather, what do we do when we don't have a right triangle?
Couldn't we just make a right triangle and figure out other angles from it?
Yes, that might work. So how do we make a right triangle out of this?
Well, we could just run another line from the ball straight down to the end line.
Yes, we could. Let's try it. By adding another line, we get a right triangle. When you want to use trig, sometimes you have to build a right triangle out of your other triangle, like this. Because we know the measurements of the soccer field, we know the measurements of this triangle. From the penalty box line to here is 54 feet, and from here to the other end of the goal is 78 feet. And we know this is a 90-degree angle. Knowing all that, we can figure out anything we want. So, Julie, what do you remember about trigonometry?
I remember that
Yes.
if you know the measurements of two sides and one angle, you can figure out anything you want to know.
And your worst subject was?
My worst subject by far, without doubt,
Yes.
home economics.
Well, no, wait a second. That's like the shop for the guys. You're supposed to breeze through that class. So now we have a right triangle, and we want to know two of the legs. The angle we want to figure out is here. Let's call it A. From that, we can figure out all our other angles. Let's label them, too. Our apparent scoring angle is B, the area the ball could go through if it weren't for the goalkeeper. The angle the goalkeeper is defending we'll call C, and the angle open to score, D. We end up with two other angles we'll call E and F. This is the angle we want to figure out right here. This is our hypotenuse here. This leg opposite me is called opposite. This leg is adjacent because it's adjacent to the angle we want to figure out. Hypotenuse, opposite, adjacent. Simple, right? Trig gives us three ratios. We can use any leg divided by any other leg to find out our angle. Just pick the ratio that you need. We know the lengths of our opposite and adjacent legs, so we'll use tangent and just divide 78 by 54. Now this is the simplest part of trig. In fact, it might be the simplest thing in all of math. To find the tangent of our angle, we just punch in our number, 1.44, into our trusty calculator here. Julie, would you mind finding the inverse tangent of 1.44?
Greg, I would love to find the tangent because this is my favorite part.
Very good. And the angle is?
55 degrees.
Thank you very much. You see, with sine, cosine, tangent, whatever, all you have to do is push a button. And it's not like cheating. You're supposed to just push the button. You see, they're all labeled right here. Our large angle A is 55 degrees. We have two other right triangles we can figure out the same way. We know the goalkeeper is covering 12 feet of the goal. That gives us an opposite leg of 66 feet divided by an adjacent leg of 54 feet. The tangent of E equals 1.22 or 51 degrees. And using the same method, F is 45 degrees. The rest is just subtraction. 45 from 55 makes our B angle 10 degrees. 51 from 55 gives us 4 degrees for our D angle over here. And if we subtract 4 from 10, we get a C angle of 6 degrees that the goalkeeper is actually covering. So, Tiffany, what does that mean?
If you take a shot on goal from out there, there's 10 degrees of effective scoring angle. But I'm guarding 6 degrees. That only leaves you with 4 degrees to score.
Oh, I don't know, Heather. You only have 4 lousy degrees to make the shot from over here, but give it a try. Okay. Don't choke. Oh, well, listen, Heather, come here. Don't take it too hard. I mean, 4 lousy degrees. Hey, don't cry. It's all right. It's okay. How about a best subject? Do you have a favorite subject?
My favorite subject was probably trigonometry.
Oh, come on.
But I'd probably say my favorite subject was creative writing.
creative writing. So not like the write about the novels you're reading, but like short fiction, poems, and that kind of thing.
Where you could kind of just write in your own voice. You didn't have to write thesis, supporting arguments, conclusion. It was like, this is me, this is what I'm writing about.
Cool. So how much better are your chances from the center of the field? Let's figure it out. First, we'll create our triangle for the total possible scoring area. So Tiffany, where are you going to line up for a shot taken from the center?
Right here in the middle.
Okay, let's bring in our line of defense. The goalkeeper can still only cover 12 feet of the goal mouth, so that leaves the same amount uncovered. Our possible scoring triangle now looks like this. Let's call it B again. If we create another triangle from the goalkeeper's line of defense, we get a second angle we'll call C.
C.
Okay, so what's our problem now?
There's no right triangle again.
Right, so what should we do?
Run a line straight from the ball to the goal line again.
Okay, let's try it. Hey, Tiffany, could you hold this for a second? Sure. Thank you very much. Okay, so we've created a right angle here, so now we have two right triangles. The reason we can do this is that it splits our problem perfectly in half. So whatever we solve for this side will be the same for this side. We have a right triangle, and we have the D angle the ball could pass through to score. We know the lengths of two of our sides just from the measurements of a soccer field, our adjacent and our opposite. So we use tangent again to get 12 divided by 54. Tangent D equals 0.22. And the inverse tangent of D is
12.5.
We figure out the angle that the goalkeeper is defending, E, the same way. Tangent. Opposite divided by adjacent is 0.11. The inverse tangent of 0.11 is... Julie!
6 degrees.
Hey, all right. The goalkeeper is blocking 6 of the 12.5 degrees on that side. So on this side, we have 12.5 degrees to score, and the goalkeeper is covering 6 degrees. And on the other side, because we split our problem exactly in half, the angles on the other side are exactly the same, 12.5 and 6. A little addition, and we see that the total angle the forward could score from is 25 degrees. But the goalkeeper is blocking 12 degrees. Subtract 12 from 25, and we get 13 degrees the forward could score in. From our side angle kick, you only had 4 degrees to score from. But from here in the center, you've got a total of 13 degrees. That's a 3 times better chance of scoring. Jennifer, you got this one nailed easy. Take it away. Wow. I'd like to thank the Neal sisters, Jennifer, Heather, and Tiffany of the American Youth Soccer League, and Julie Foudy for helping us out today on ESPN SportsFigures, the Trig of Soccer. Hey, Julie!
We'd like to thank all the sports figures who participated in today's show free of charge. ESPN SportsFigures is presented commercial-free for educators to tape and use in the classroom. Comments or questions about sports figures? Drop us a note at ESPN Plaza, Bristol, Connecticut, or the website on your screen. To order a free teacher's curriculum, call 860-766-2000, or better yet, go to the SportsFigures website for all sorts of cool stuff. This has been a presentation of ESPN, the worldwide leader in sports. For more, log on to ESPN.com, part of the Go Network. Go.com. SportsFigures. Put your brain in the game.
The preceding program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
ESPN SportsFigures, presented by Go Network.